Now, we're going to do another one. Example number 5. Draw a relative frequency histogram for the frequency distribution in example 2. Okay, so again, I'm going to relative frequency. It sounds a lot like a frequency histogram that we did back in example 3, except now we're dealing with relative frequency. So what's the difference? Well, it kind of starts off the same. I'm going to be honest. Boom, I'm going to put him in there. But I don't want frequency here. So let me change this color. Let's see. We're going to do... I don't know. Maybe we do this one in blue. That color blue. That looks good to me. Okay, kind of dark. But anyways. I don't want just plain Jane frequency here. Great. Okay. I need to have relative frequency here. So remember, relative frequency, that's the one that's decimals. So for this first one, I think I'm in the wrong color. Let's see. That color. There we go. Yeah, that matches now. Okay, so relative frequency. I'm going to count by... So our highest relative frequency in our graph, not our graph, sorry, our chart, highest one was 0.23. So maybe I'd count by 0.5s. So I am going to kind of erase this. You're like, but why is it? I thought it's the same. The shape is going to be the same, yes. Now, come back. Baby, come back. You can blame it all on me. Come back. Come back. Okay, let me do this. Select, I'm going to select just him and delete. 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 Okay, there we go. So I'm going to count these off by 0.5s, or sorry, 0.05s, I should say. Counting them off by 0.05s. Like that's going to be 0.05. That's going to be your 0.1. And then like 15. 18. Well, that looks terrible. And then 0.25. Okay, so there's a relative frequency histogram. So they don't tell us to describe any patterns on it. I mean, mainly because it's the same exact histogram. You just have relative frequency instead of normal frequency. So you have decimals instead of whole numbers. Okay, and then, nope, come back here. There we go. Then the last one we're going to look at is called a cumulative frequency graph. So I know this video is longer than the 20 minutes, but I'm trying to keep all the graphs together. Example number 6. Draw a cumulative frequency graph, which is commonly called an ogive, for the frequency distribution in example 2. Describe any patterns. I'm just going to say no. Any patterns. Okay. So now, for a cumulative frequency graph, they typically use class boundaries on the y-axis. Sorry, not the y, on the x-axis. So I'm going to actually come up here just to, again, save us some time here. Already over our time. So I'm just going to copy him, paste him there. Delete, 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 delete. Okay. I need to delete all of these rectangles. At least our axes are here. Okay, on a cumulative frequency graph or an ogive, we typically do upper boundaries. This is going to be cumulative. Okay, now you're like, okay, so you're just going to start numbering yes and no. I'm not going to do 1 through 7. This is cumulative frequency we need to do. So I'm going to count by 5s. 5, 10, 15, 20, 25, 30, 35. Okay, I know we don't have 35, but just anyways. So we're doing, again, cumulative frequency. So for this graph, what is my frequency before I even have my very first class? If I look, whoa, where did it go? There it is. Before I even have my first class at 154.5, do I have anything yet? No. So I do 0, and then I just follow my cumulative frequency column. So 0, 3, 5, 10, 16, 23, 27, 30, on down. So that's what we're going to do here. At 154.5, we have 0. Then we go to like 3. And then we have 5. And then we have 10. And then 16. And then 23. And then 27. We're getting closer. Until we finally get to 30. And then I draw line segments to connect them. Boop. 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 I'm just not I'm not a great artist, so just doing my best here. all I ask of y'all. They're supposed to be smooth. They're not. But anyways. Okay, so what does this graph tell us? Well, one thing that this graph will tell us, if you look at this top number right here, this will tell you the sample size. So sample size equals 30. That last class, that upper boundary, it's cumulative. So that tells you sample size is about 30. Now, you could also look at the steepness of the line and say, well, the greatest increase is where the line is the steepest. So that would be between 298.5 and 334. So steeper, that means it has the greatest increase. And so those are two observations you could get from an ogive. But anyways, we are well over our 20 minutes. I should probably have broken this into 2 videos. But anyways, this is the end of section 2.1. So frequency distributions in their graphs. Remember that you're loved. You are created to do wonderful things. And you are awesome. Always believe.